Good evening, children. Welcome to your chemistry class. Today, in this chapter of nitric acid, we shall continue studying manufacture of nitric acid by Ostwald's process. By Ostwald's process. Okay. This process takes place in three main steps. So, what are those steps? Step 1 is your catalytic chamber. Catalytic chamber. Step 2 is your oxidation chamber. Okay, oxidation. And step 3 takes place in absorption chamber. So, this manufacture of nitric acid happens by what process? By Ostwald's process. This Ostwald's process is completed in 3 steps. What are those 3 steps? They are passed through catalytic chamber, then through oxidation chamber and through the absorption chamber. Now let us first discuss about the reactants that are used in this process, right? So the reactants that are used in the manufacture of nitric acid are dry ammonia gas. We use pure dry ammonia gas and pure dry oxygen. Clear? Now what is the pure dry? When I say about oxygen, I mean to say it should be free from carbon dioxide, water vapor and the dust particles. Clear? The ratio of ammonia and oxygen should be 1:10. What should be the ratio between ammonia and oxygen? 1:10. Now, why such a high ratio of oxygen we are using over here? One thing you remember, if the question says what is the ratio of ammonia and oxygen, you will write 1:10, not 10:1. Okay, or if I say what is the ratio between oxygen and ammonia, if your answer is 1:10, remember it will be wrong. So you have to be very particular as to what ratio the question is talking about over here. Now coming to why the ratio of this oxygen is so high. Because the air is used in all the 3 different chambers, right? For the manufacture of nitric acid, this oxygen, it is used in the catalytic chamber, in the oxidation chamber and also in the absorption chamber. And we know that only 21% by volume of air is oxygen, and therefore the ratio has to be high. I hope this point is clear. Second important point, if the concentration of the reactants will be more, then the forward reaction will always take place. So this is also one of the reasons why we take higher ratio of the reactants. Then here the gases that are entering, they should always be in their pure form. Why? Because as we move to the first step, that is the catalytic chamber, as the word suggests, catalytic means we are going to use some catalyst over here. So if there is any impurity present in these 2 gases, then it may lead to poisoning of the catalyst, which will lower the efficiency of its work. I hope this is very clear to you. So what are the reactants we are going to use in the manufacture of nitric acid in Ostwald's process? 1 part of ammonia and 10 parts of oxygen. Now you must be knowing what are the reasons why we are using such high percentage of oxygen. Next we come to the first step now. We begin with the manufacture of nitric acid. Now look at the first step, that is the catalytic chamber. Okay, so what happens firstly in the catalytic chamber? In catalytic chamber, oxidation of ammonia takes place to nitric oxide. That is, what conversion are we going to study over here? What conversion are we going to study over here? That is catalytic oxidation of ammonia to nitric oxide we are going to study. So let us see the reaction over here. 4 parts of ammonia, they react with 5 parts of oxygen. What did I say? The ratio of your reactant should always be high so that it favors the forward reaction. What is the catalyst used over here? Platinum, right? What is the temperature to be maintained over here? 700 to 800 degrees Celsius. So this platinum is initially heated at 700 to 800 degree Celsius, and thus when we pass ammonia and oxygen through this catalytic chamber, it gives us what? Nitric oxide, NO plus 6 parts of water. It is also an exothermic reaction, and therefore lot of heat is given out in the form of energy. How much? 21.5 kilocalories. So we can say it is a catalyzed reaction. Why? Because we are using a catalyst over here. What is the catalyst? That is the platinum that we are using over here. This is the platinum gauge. What is the temperature that should be maintained here? 700 to 800 degrees. What is the nature of the reaction? It is an exothermic reaction. What are the reactants used over here? They are pure dry ammonia and pure dry air, which is free from carbon dioxide, water vapor, and even the dust particles. I hope this is very clear. What is the ratio of ammonia and oxygen that we are using initially? They are in the ratio 1:10 by volume. Right? Over here, what happens? 95% of ammonia, right? It is converted into this nitric oxide. Fine? And the remaining means 5% it is left to burn to nitrogen and steam. So in this, once again, the gist of catalytic chamber, that in the catalytic chamber, what is the catalyst we are using? Platinum gauge, which is initially heated. Then this is the catalytic chamber in which the nitric oxide is formed over here, right? It is an exothermic reaction. Since the reaction is exothermic, therefore the electrical heating is done initially, and the heat evolved, that is the heat of reaction, further it maintains the required temperature of the reaction. And further, in the second step, we do not require any more heating. Why? Because it is already an exothermic reaction. I hope this is very clear to all of you. We next move to the second step. What is your second step? That is the oxidation chamber. We next move to oxidation chamber. What do we study in oxidation chamber? The gases which are leaving the catalytic chamber are what? Your nitric oxide, right? And this is passed first through the cooling coils before it enters into the oxidation chamber. Now, the gases, why are they passed into it? They are passed through this heated exchanger or through the cooling coils, so that the gases, they cool down. The gases, they cool down. And what is the temperature that is required over here to cool it down? It is approximately 50 degrees Celsius. So over here in oxidation chamber, what is the conversion we need to study over here? That is the oxidation of nitric oxide takes place to nitrogen dioxide gas over here. So the reaction, what will be the reaction? Two parts of NO, they react with the oxygen which is still present in the chamber, and this is cooled by passing through the cooling pipes at what temperature? 50 degrees. No more heating required further. And this gives us nitrogen dioxide gas. So here low temperature is required. Why low temperature is required? Because this low temperature facilitates easy oxidation of this nitric oxide to nitrogen dioxide, and it also minimizes the chances of any decomposition of nitrogen dioxide further, which might take place at higher temperature. Clear? Therefore, this low temperature is a must. This is to be used over here. Then we move to the third chamber. What is the third chamber? The chamber. Okay, so which gases move to absorption chamber? The nitrogen dioxide is going to move to the absorption chamber. Clear? The gases which are leaving the catalytic chamber, they were the nitric oxide. This nitric oxide went where? To the oxidation chamber. The oxidation chamber converted it into nitrogen dioxide at what temperature? 50 degrees. Now here in the absorption chamber, what will happen? The gases which were leaving the oxidation chamber will now move to the absorption chamber, right? And this absorption chamber, it is packed. It is packed with quartz. It is packed with quartz, right? Layers of quartz is placed over here. Why? This whole the absorption tower, it is a steel tower. Okay, it is filled with the quartz and it has a spray of water trickling from the top. Got it? The gases which are namely over here, what? That is nitrogen dioxide and the residual of the gas. What is that? The oxygen. Over here they combine. And what do they form and how do they combine? First, let us see that. So over here, 4 parts of nitrogen dioxide combines with the water that I told you it is trickling, or the spray of water is trickling from the top, and the residual oxygen which is left back for the absorption tower. They all combine together and they give us this nitric acid. Is this clear? What is the temperature? Ordinary temperature. Over here in the absorption tower or in the absorption chamber, there is a ordinary temperature. And what is the product that is formed over here? Nitric acid is formed here, right? Now, why did we use quartz? What is the reason of packing this absorption steel tower with the quartz? Because quartz it is acid resistant. It is acid resistant. Clear? This is one of the reasons why we use quartz over here. Okay, this quartz, it is packed in layers. Because why it is packed in layers? Because it slows down the movement of the gases like nitrogen dioxide entering from below, and it also initiates better solvation of nitrogen dioxide in water. Clear? That is why layers of quartz are used in the absorption chamber. I repeat, why do we use quartz? Because it is acid resistant. First point. Now, why is this quartz packed in layers? Firstly, because it slows down the movement of the gaseous NO2 which enters from below, from lower part, right? And it also helps for better solvation with the water over here, thus forming nitric acid. I hope this is very clear to all of you. Now, nextly, I want to talk about the product that is formed over here. That is the nitric acid. What do we know about this? This is the dilute nitric acid which is collected just now where at the base of the absorption tower. Clear? This dilute acid can be further concentrated. Now, firstly, what is the percentage of nitric acid, dilute nitric acid that we have collected just now? Only 50% nitric acid. It is dilute and it is collected at the base of the absorption tower. Now, it is concentrated by either distillation or boiling. Till what? Till the constant boiling mixture is obtained. And what is the constant boiling mixture for this nitric acid? It is the constant boiling mixture is 121 degree Celsius, and this contains 68% nitric acid. I hope this is very clear. So what did I say? What kind of acid do we obtain in the absorption chamber? It is the dilute nitric acid that is obtained where? At the base of the absorption chamber, and it can be further concentrated, right? So how can it be further concentrated? By distilling or by boiling. How? The constant boiling mixture at what temperature? At 121 degrees Celsius. What percent of nitric acid is obtained? 68% nitric acid is obtained. This 68% nitric acid can be further distilled with concentrated sulfuric acid under reduced pressure, and this will result in 98% fuming acid. By this we will obtain 98% fuming acid. So how will we obtain 98% fuming acid? How? By further distilling this 68% nitric acid with concentrated sulfuric acid. How? Under reduced pressure. This will form 98% fuming acid. I hope all these three steps are very clear to you. Now we shall move to the physical properties of nitric acid. Now let us begin with the physical properties. Physical properties of nitric acid. What do we know about the color? Color, pure acid which is 98% purity we are talking about. It is always colorless. Okay. But the 68% that is obtained, okay, that is called as the commercial acid. This is 68% is your commercial acid, and this is always yellowish brown color. Okay. It is always yellowish brown in color. What do we know about the odor of it? It is quite suffocating. What do we know about the taste of it? It is sour taste because it is an acid. What is the physiological nature of this acid? It will be always highly corrosive. It will always be highly corrosive. You know, when it drops on your skin, it causes painful blisters. It combines with the protein of your skin and forms a yellow compound that is called as xanthoprotic acid, and this stains the skin yellow. Clear? So we can say it is highly corrosive in nature. Then what do we know about the density? Density, it is always heavier than water. It is heavier than water. Okay, this I should write over here. Corrosive in nature. Corrosive in nature. Okay. Then next point, what do we know about the solubility? Highly soluble in water. Highly soluble in water, right? What is the constant boiling mixture or azeotrope? Constant boiling mixture, as I have already told you, what? 121 degrees containing 68% of nitric acid is your constant boiling mixture. Clear? What is the boiling point of it? Boiling point of pure acid. Pure acid, this time I'll tell you what is pure acid. It is 86 degrees Celsius, and it also freezes. Its freezing point will be minus 42 degrees Celsius, or you may say its melting point is minus 42 degrees Celsius. Now, once again, going back to distillation or boiling, it cannot be used to concentrate the nitric acid beyond a certain concentration. So, first point that I told you, in an aqueous solution of nitric acid, how is it formed? At constant boiling mixture. What is that temperature? 121 degrees Celsius, which contains 68% nitric acid. Clear? This constant boiling mixture, what do we understand here? The mixture boils without any change in the composition. Hence, on boiling, above mixture evolves all the vapors of both acid and water in the same proportion as in the liquid state. Now, this 68% nitric acid, that cannot be concentrated beyond 68% by simply boiling. So how can we further get this 98% pure acid? Further concentration of this acid is only and only possible by the distillation of acid under reduced pressure in the presence of, what did I tell you, concentrated sulfuric acid, right? So this 98% pure acid that I have written over here, this is also called as fuming acid. What is it also called as? Fuming acid. Clear? And we can also obtain from this fuming acid, we can also obtain 100% pure HNO3. How can we obtain this? By cooling this 98% acid. When we obtain colorless crystals of pure nitric acid. Okay, and this can be separated at what temperature? At -42°C. So this 98% fuming acid can be converted to 100% pure crystals at what temperature? -42°C. And this 100% pure nitric acid is also called as anhydrous nitric acid. Okay, so what did we study? That at 121°C we are obtaining 68% nitric acid, which cannot be further concentrated by boiling. It can be converted to 98% fuming acid. How? Under pressure in the presence of concentrated sulfuric acid. And further we can obtain 100% pure nitric acid by lowering the temperature to -42°, and we get pure crystals of HNO3, which is also called as anhydrous nitric acid. So in this video I stop over here. Next time I shall come back to you with the chemical properties of nitric acid. Thank you.